All right, welcome and thank you for joining today's webinar with co-founder and CTO of InGuardians, Jay Beal, in attacking and defending the Donkey Docker Capture the Flag. You're also joined by BeyondTrust Product Manager Paul Harper, who will run us through an overview and demo, if we have time, of PowerBroker for Unix and Linux after Jay's presentation. So I encourage you to stick around for that portion. My name is Sarah, your webinar host today. A kind reminder to please submit your questions via the chat box in the GoToMeeting console anytime throughout the webinar, and we'll cover your questions at the end during our Q&A time. Also, today's session is being recorded, and all registrants and attendees will receive a link to the recording and the slides within 1 business day from now. So at this point, let's hand it on over to Jay, who will jump right in. I know he has a lot to cover, so Jay, welcome aboard and take it away.
Thank you very much, Sarah. Hello, happy Hackadays. Well, so today we're going to play one of the one-person capture the flag virtual machines that you can get from VulnHub, and I'll show you where we're going with that. So, okay. So we're going to do a few slides, and then we're getting hardcore into demo mode. So here's our agenda. So first, we're going to hack the Donkey Docker capture the flag. And try to get 3 flags, and we're going to try and get root. And then we're going to put our defender's hat on, and we're going to break the exploit. So we're going to try to break the exploit's reverse shell, and we're going to try to break the exploit at a more fundamental level. I really like doing things like this. I've done a number of these kinds of webinars where I'm trying to basically take one of these capture the flag machines and hack it, and then I'm trying to say, wait a second, this thing shouldn't be as hackable. What if we can break the way the attack works? And I've been teaching this kind of stuff for a long time at conferences like Black Hat, and I've been finding it's a lot of fun to look at it from an attacker's perspective, which is honestly what I do in my day job a heck of a lot more than defense over at InGuardians. So anyway, I'm gonna walk you through one of these, and this one is the Donkey Docker capture the flag, or the Donkey Docker boot to root virtual machine that you can find on VulnHub. And VulnHub is this great site that has a whole pile of these kind of single-person capture the flag challenges that people will create, and they'll upload. They'll upload them as virtual machines. You download it. You try to go through and get the flags, and almost always in getting the flags, you're trying to root the system. So you can go into VulnHub, you can download the Donkey Docker CTF, you can go and get your own Kali Linux system, or if you've got your attack tool set up on your own machine separately, you can use it that way. And you can practice this not just with the Donkey Docker CTF, which we're going to do here, but go and grab some of the others, because these are a heck of a lot of fun. So we'll come back to the slides at the end, but I'm going to go straight into demo. Now, what you'll find with my demos is that I have recorded them all, and I record my demos because I have a distinct fear of the demo gods. The demo gods are, as I understand it, descended from the trickster god Loki, and wow, do they really get pissed if you try to do anything in front of people. So I just record it, and we get some other benefits out of that, like the ability to fast forward where we want. So we're going to start here. I've got 2 virtual machines running. One's Kali Linux, the other's that Donkey Docker capture the flag machine. And this is start to finish how you would root the Donkey Docker machine and get the flags. So the first thing we got to do is on our Kali machine, we got to figure out what our IP address is, and we're going to do that because we need to know the Donkey Docker's IP address. So we just run IPA and get that really quickly, and then we fire up Nmap and we do an ARP scan against the address space that we're sitting in, because all the virtual machines running in VMware here are going to get addresses from that same space. And here we go. We find the Donkey Docker one, and the Donkey Docker one, you'll notice, has a name. It wouldn't normally have a name. I've just hacked that for the purposes of our demo today. I've put Donkey Docker in my etc hosts file on the Kali machine so that we can refer to it by name and not have to keep typing IP addresses, and so it's a little more clear. So we see that there's a Donkey Docker virtual machine here, and that it's running 2 ports open. One's SSH and one's port 80, a web server. We didn't. I'll tell you that I tried on the SSH and didn't find something really. Didn't bore fruit there. So let's go and look at the web server for Donkey Docker for this machine we found. So we fire up a browser on Kali. Here we are. So we go to this, and this is the kind of welcome page. Welcome to the contest, and you find the author says, here's where to find me on Twitter. At this point, what we're doing is like saying, okay, we've got a web app. What can we do with this web app? And you just basically want to enumerate and explore it. So we got the home page we're on. We've got the about page. It doesn't do anything. It says something goes wrong. I've gone through, and you might also view the source on that page and on all the other pages, and I've done that. I've chopped that out to keep this video tight, but suffice to say that the about page, the home page, and the contact pages source don't turn out to be all that useful. So okay, this is what we can see of the app so far. We've got a home page, we've got a contact page that's a form where you can put a name and an email and a message. And well, what's the next thing we might do? The next thing we might do, very, very common, is go look at the robots.txt file on a server. And the robots.txt file on a server is, it's basically where the server admin, where the web server admin lists all the parts of the site that they don't want crawled by bots. Sometimes they're embarrassing stories they're embarrassing stories that they have to keep up for public record on a government website or what have you, but they don't want you to see. Sometimes they're useful functionality. We just always hit it. In this case, the robots.txt just shows us the 3 pages we've already found: that about page, the contact page, and the I'm sorry, and the main page. So that wasn't useful. So the next thing I like to do here, and this is a pretty common thing to do with these in particular, or with any web server you're attacking, is fire up something called dirbuster. And dirbuster is this great little tool. It comes from, it's an OWASP project. It is incredibly common. There are other tools that do the same thing, where you basically give it a list of sample URLs to search for at a site, and they'll be like, there'll be common software that's out there. So in a past webinar, we found WordPress that way. There'll be common file names, common directory names, and honestly, even things that tend to be vulnerable. And so to use your dirbuster is pretty simple. We put in a URL. Because of my Etsy hosts entry, we can just put in Donkey Docker and port 80, and then we choose a list of those files. So dirbuster actually comes with a bunch, and this being Kali Linux, they've put every tool on here has a directory in user share that's named for it. So we're going to go to user share dirbuster and find those word lists, find those path lists of files and paths to search the server for. So we're going to user share dirbuster into word lists, and we're going to choose the medium one. You can choose all different ones. You can choose ones that are longer. The longer ones will have better odds of finding you something juicy, but they'll also take longer to run. The medium one, actually, this one took longer to run here, and I've cut this video so that you're going to miss about 4 minutes or 5 minutes of waiting. But this basically runs, and you'll see that it's firing 433 requests every second at the web server. It thinks it's going to take about 2 hours to finish, and it's trying 10 threads at a time. And you can tune that, but what I do here is keep it with these settings and then fast forward in time. So here we are at the end, and we're going to find that there are we're going to find there's some interesting stuff. If you look on the left side of the screen at all this text in the good font instead of the text in the tiny font on the right, you're going to find that there are paths or file names. It says dir found and file found, and then there are status codes. And we all, if you look up the HTTP status codes, you'll find 200 means, yeah, you loaded it A-OK. And everything else generally means do something different. 403 is forbidden. 500 means something went wrong. So we're looking for the 200s. And the reason I chose to stop the dirbuster run at this point was I have this 200 on mailer examples. And I say that's probably going to be really useful. So I've got mailer examples. And that sounds like useful functionality to find on the website, especially given that we found something that seems to do something with email in some way. Okay, so let's take this and let's go and browse to that. Let's go and browse to mailer examples in our browser. And you're going to notice that a lot of my URLs have autocomplete going because I've been practicing this demo a number of times before recording it. So here we are. We find ourselves on this PHP mailer code examples. So that tells us we got PHP mailer in play. And you could walk through those code examples and see if you can find anything useful, maybe some default passwords or such. I've done that. It didn't bear fruit. But what does bear fruit is the PHP mailers had a good number of vulnerabilities. And so if we look in the upper right corner, the nice thing is they even give us a nice URL that we can use to learn about PHP mailer and look at its code. So let's go take a look. So here's PHP mailer on GitHub. We could look for its security history, but right now I'm looking for something in particular. I want to know whether this thing tells an attacker its version number. And this one does. It's got a version file where if the person deploying PHP mailer on this machine didn't cut the version number out, then it's waiting there for us. It'll be waiting there for us right there. So let's give it a try. Let's go to donkeydocker/mailer, and then instead of examples, we'll try version. Oh, hey, there's a version number. Now that's useful because now I can see if now I know what version of the PHP mailer software is there, and I can go search for that. So the cool thing is that Kali Linux comes with Metasploit, and I know I've used Metasploit in some of the webinars I've done here in the past, and so I really wanted to use an exploit that wasn't for Metasploit. There is a Metasploit exploit for this. We're going to do it a different way. And the cool thing is that Kali Linux comes with a mirror of a site called exploitdb.com. And exploitdb has a ton of exploits against software, and what Kali does is they not only made a mirror, but there's also a tool called searchsploit. And searchsploit, you put in searchsploit and then some string, usually the name of the thing you're looking for, and it says, oh, here are exploits you could find, and here are version numbers which are vulnerable to those given exploits. So we see a pile of them, and I'm just going to choose the fifth one down. And I didn't really choose it at random. I looked at them all and chose one that was easiest and worked best, and honestly was in a language I liked. So this one's in Python, and so we're gonna use that one. So I'm going to copy it from the directory. If you look in the upper right, it says all the exploits are in user share exploit DB platforms, and then it gives you a path. So we'll copy that exploit out of there because we're going to have to modify certain lines in there. So we'll copy that exploit, and now let's look at it. And we look at it, and I hit V to edit it in a second. And this is our exploit, and there are two variables I've got to change. The one is I have to put in the IP address of the Donkey Docker machine, and the port, and the URL that's vulnerable. So that contact form is what's going to have PHP mailer writing behind it. So I'll put in that contact form as my target, and then I have to modify the payload to change the IP address that this thing connects back to. So this exploit is going to, at the end of the day, cause code to connect back to my system. So I'll have to have a netcat listener to listen for that, and I have to tell it what the IP address of my Kali system. So there's my Kali systems at 231.132, and the Donkey Docker systems at 231.141. So the way this thing works, the way this exploit works is when I fire it off, it's going to place, you notice this backdoor.php, it's going to create a PHP file on the web server called backdoor.php. And that backdoor is going to include, among other things, this payload string that we've got here. And that payload basically tells PHP to run a shell that runs some Python that connects back that connects back to our Kali Linux system. So the way this is going to work is we're going to fire the exploit at the system. It's going to create that backdoor PHP. We're going to have a netcat listener set up, and then we're going to serve to that backdoor.php with our browser, and that's going to cause the backdoor to open, as it were. It's going to cause the machine to connect back to us to make it outgoing connection. So we'll set up our netcat listener to just listen on 4444, HD Moore's favorite port. And now we'll fire off the exploit. Okay, so our exploit says, hey, I'm sending the evil shell to the attacker, setting it up. And now what I need to do is, I've got the netcat listener, I need to fire up that browser again. So I'll fire up the browser, and I'm going to go to donkey docker /backdoor.php. And it says connecting. It doesn't seem to be loading. Something weird's going on. Oh, I've got my shell. Boom. So here we are. We're on this donkey docker machine that we've connected to. So 231.141 has connected back to us. And the first thing I do is find out what user am I? And so I run ID, and it says you're the web server's user. www-data. Man, back in the old days, it used to just be root. But it's been a long time. So the other thing I noticed here was that this thing says, hey, you don't have a proper TTY, so it's going to be a kind of funky shell. And there's an oldie but goodie thing that everybody just basically does over and over again. Honestly, if you could watch your servers for something like this running, it might be useful. We basically say, okay, I'm going to create a Python program. The Python program is going to use the PTY module, and it's going to spawn a bash shell in a proper PTY. So here's what I've just created. I just created a 2-line Python program, and now I run that Python program, that shell.py, and now I've got something that looks a lot more like what I'm used to when I log into a Linux system. It says www.data at, and it has a funky host name. This isn't any kind of host name I'm used to seeing. 1208. It's kind of looks like it's basically in hexadecimal. That makes me start thinking about the fact that this thing's called Donkey Docker. So I may be in a Docker container. I'm going to find out soon. So I do an ls-l and look around, and okay, I'm in the web space. And outside of shell.py, everything in here is the kind of stuff I was seeing from outside. So I've read through this, and none of it really bore any fruit. So let's look at the root of the file system. So cd/, try to clear my screen. I can't clear because there's no term environment variable set. This is some I've seen, and so I put in a term, and this was actually the first terminal I ever emulated with a modem. So I put in VT100, and now I can clear the screen, and I do an ls-l, and I see normal stuff, except I see one file that looks a little strange, this main.sh. This main.sh about halfway down the page. So that's not usual. So let me cat that out and see what it looks like. So main.sh, it starts out, and this first line is really useful. It starts out and says it wants to make sure that Smith is the owner of a flag file. Remember, I'm looking for flags. So I know that I want to read that flag in home Smith. So let's try. Cat home Smith flag.txt. Every now and then, permissions are world readable. It turns out this one's better protected. So I need to be Smith. And there are lots of different kinds of things I might try to escalate or modify privilege over to Smith. But it turns out that the easy thing here works. I su to Smith. I try to use Smith's username as his password, and it works. And now I can cat out that flag.txt. And here we go. We've got the first flag. And these are kind of fun. Every time you get one of these flags, you get a little dopamine rush, and it's fun. If you've got the Hack-A-Days off, then I definitely would recommend playing with one of these. So we've got our first flag, and it says that he likes 1984 by George Orwell. Cool. We got the first flag. So now we got to figure out what else we're going to do. And I asked this thing for its IP address, and I noticed that I've got 172.17.02. That's not the thing I connected into. What it is, though, is the default IP address that you get on the first Docker container, the first container in a Docker system. So it's pretty clear I'm in a Docker container at this point. So let's keep looking around. Let's just treat it like a normal system. I list Smith's home directory, and I see the flag, and I see a bash RC and a profile, and I could look at those, and I have, and it didn't bear fruit. But I also find an SSH directory. And lo and behold, that SSH directory nicely has an SSH public key and an SSH private key. So I'm going to look at the public key first because it tells me the username that created this on some other system. So somebody who was named Orwell on that other system called Donkey Docker created this. Wait, isn't Donkey Docker the thing I'm trying to hack? Okay, that's useful. Okay, now let's look at that private key. So we'll cat out the private key, and I'm going to cat out the private key, and then I'm going to capture it. I don't want to keep trying to work from this, from this kind of, weird shell that might fall down at some point. I want to just take it, and I'm going to go to my own, I'm going to go back to the Kali Linux system itself and try SSHing in to the Donkey Docker system with that account, with that SSH key. So the first thing I do is write that SSH key out to a file. So I'll cat out to orwell.key, I'll paste, and then I'll hit Control-D. Okay, so now I need to make sure the permissions on that file are good, otherwise SSH won't let you use it. So I use SSH-I, Orwell key, and then we'll try the Orwell account at the IP address that was Donkey Docker. And here we are. Well, that's cool. So now it's like Inception. We're in the outer host. I run IP and A, and I see there's a Docker bridge there. So this machine's definitely running Docker. It's probably running the thing that we were in. And I do an ls, and I see a flag. So let's look at that flag. Second flag. Cool. Okay, these things almost always have 3 flags, and the third flag almost always depends on getting root. So I just noticed something though. When I ran ID, first thing I run whenever I get into a system or into a new account, I'm in the Docker group, and you really want to watch out for who's in the Docker group, because anybody in the Docker group can do, well, they basically can get root on the system as we're about to, and they can do anything to the Docker containers they want to. So be really careful. So what I'm going to do is I'm going to run Docker PS, and if you do a search on my full name in Docker, you'll find a nice Docker walkthrough that'll teach you how to do some of this. So I'm basically going to, if you're not familiar with what I'm doing next, I'm going to talk through it a little bit, but you can really get into this if you find that past talk or slides I've done. And I think my next Beyond Trust webinar is actually going to be involving Docker. So we're going to use Docker PS to see what containers are running. We see that there's that Donkey Docker container, and the container ID is the same as that funky host name we found before. So we definitely were in a Docker container running from this host, exposing port 80. So what else can we do? Let's ask Docker what images we can start up a container from. This is kind of like what virtual machine templates it has. And it says it's got 2. It's got a Donkey Docker one, and it's got a straight Debbie and Jesse, which it turns out was used to build the other one. Well, Debbie and Jesse will work for me because there's a nice little Docker trick. And what we're going to do is we're going to launch a container. Docker run -IT means interactive. -V is a special option, and this special option is what is going to let us root the what is going to let us root the Docker host. And we basically say, hey, I would like to take the root / of the Docker host, and I'd like to mount it in the Docker container as /root. And so /root in the Docker container will be replaced with this file, with the overarching / file system from the host. And we can do that with any container we want. I'll choose Debbie and Jesse because it's there and it's a known quantity. And I want to run a bash shell in it. That's, by the way, how fast it is to start a container. This is part of the reason people love using containers in their labs to do development instead of virtual machines, because they take no time to start up and they use very little resources. So here we are, and let's go into /root. And when we look in /root, we find the root of the host file system. Well, now that's going to be hella useful, because we are running as root, and we got that file system read write, so we can make any modifications we want. So let's do this. Let's switch into that root directory. We see a flag. This is basically where it would normally end. So we cat out the flag. It says, hey, you did it, you won. Drop me a line on Twitter. Here's your last flag. We're going to go further though. We're going to go get root on the system fully. And the reason we're going to do that is because we're next going to try to do some things to break the attack. We're going to harden that system. So to harden that system, I want root on it. So the first thing I do is I use chroot, and I use chroot so that I'm basically saying, hey, I'd like the root of my file system until I type exit to be this /root, in essence to be the host. So now it's like I'm really root on the host, and I'm going to use that to create an account. So the easiest way is I want to add an Etsy password, an Etsy shadow entry for a new user. I'm going to copy that straight out of root. So I'm going to take the root line out of Etsy password, and I'm just going to change the username. And I'm going to add this line. I'm not replacing the root account. I'm adding a new account to it. Now, if you're watching for changes to your Etsy password and shadow files, this would definitely trigger an alarm. Okay, so, and then I'm going to go and do the same thing with the shadow file. And you might say, wait, you don't know the root password on this system. And I'll say, that's fine. Honestly, I could create these from scratch. I could create these lines from scratch, but I find it easier and less error prone to do it this way. Although, speaking of errors, I just overwrote the shadow file. There are no other accounts. So, wow, I just caught that. So now I'm going to set a password for my new account, for my hack account. I've set it to hack. It is short, but it's been allowed. And now I need to exit out of the chroot and exit out of the this SSH session. Or actually, I'll stay in the SSH session, but let me SU to hack to my root user. So here I am. Now I'm root on the system. Okay, ding, ding, ding. That's of course where I get a rush. And now what I want to do is talk about what we could do to break that attack. So if you noticed in the attack, I know it went by pretty fast, but the first thing that happened was we set up an exploit on the system, and that exploit connected back. That exploit caused the machine, caused that Docker container to connect back to our netcat listener. Now, that's kind of weird because at the end of the day, your web server, like you set up a web server, and think about the purpose of the web server. Its purpose is to sit there and listen for incoming connections and answer those connections. It shouldn't be making any outgoing connections. There are use cases where it might need to, but this either isn't one of them, or if it is, it might need to connect to a mail server. So every one of your, in my mind, every one of your servers should have a strict egress filtering set, egress, outbound firewall rule set that says what machines on the internet it can connect to. Whether that's enforced on the machine or enforced in front of it, it should be enforced. And if I make it so that the machine can't make outgoing connections, well, then I break that payload. I break the exploit connecting back to my netcat listener. So let's look at what we could do here. So I can look at on the Donkey Docker, host system, I can look at the firewall rule set by running iptable save. I could use other commands, but I'm going to run iptable save, and I can look at how this thing works. And don't worry if you're not following all of it. This is the very standard thing you get if you say I want to start up a container and expose one port. But there's one particular line that I'm going to highlight, and that line basically says, and it's right here, that line basically says, well, so I've got a couple lines that I'm highlighting, it turns out, remembering my own demo. These lines are basically saying, okay, NAT the incoming traffic to port 80. But then there's one more line, and this line here basically says, hey, if there are packets that are coming in from the Docker machines, in from the Docker bridge, Docker 0, and are going out on an interface that isn't Docker 0, then allow them. So this is basically saying let the Docker machines talk to anyone on the internet, not necessarily the other Docker machines, or that's the configurable thing. But what we can do is say, no, wait a second, I'd like to make it so that the only outbound packets that are allowed from the Docker machines are ones that are not new connections, that are not new outbound connections, that are established related. And so we're going to add 2 lines to our firewall rule set. So I'm going to put in IP tables, then -I means insert into the forward table, at position 4. I know this is a little weird to look at. IP tables, there are strengths and there are weaknesses of this approach, but it lets you add and remove and replace firewall rules right from the command line. The positive is that you get to see the impact of what you did really, really immediately. So we're going to insert at position 4 before that specific rule that said just allow anything out from the Docker machines, something that says if something's coming from the Docker machines and it's going out, it's not going to the Docker machines themselves, let's use the connection tracking module and say if it's a new connection, I'm going to log it, and then I'm also going to drop it. And I'll say log, and log prefix is what do I want at the beginning of the log message. I'll make it say outbound from container, and then it'll have some information about the packet. And then I'm going to put in another rule, and this rule is a drop rule. So the log rules in IP tables just write to the logs. They don't say what to do about the packet otherwise. So we're going to have to put in another rule that says okay and also drop it. So now let's turn around and try our attack again. So the exploit put the backdoor on there. So all we have to do is try to trigger the backdoor. And when we try to trigger the backdoor, go to our netcat listener, nothing happened. Okay, so nothing happened, and that's good. Now let's go and take a look at what happened in our logs. Let's see if nothing happened because of the new firewall rules we put in. So I'm going to look at the last few lines of our log messages. And the last two will be me SSHing in. So the first one is the one that says, hey, I blocked something. I'm about to block something. Outbound from the container. The container wanted to make an outbound connection to 132 to your Kali Linux system, and that's what got blocked. Okay, so that's the first way that we can break the attack. And I'm going to talk about a couple more. So I'm going to switch us back to the slides now. So we did egress filtering. We basically said our web server doesn't need to make outbound connections to any arbitrary attackers, IP addresses. I like to think, like part of my security modeling is to think instead of always saying, okay, the user interacts with the application in this way. When I'm trying to do a security model, I say the attacker interacts with the application this way. The application makes connections to attackers. So our web server doesn't need to be able to, so we can put a default deny firewall in place. That's what we just did. If it turned out that our web server did need to be able to make connections to specific IP addresses, we could do what we do on inbound rule sets. We could go and basically make a list of them and put them in. So what else could we do to block the attack? Well, another one is, you notice that when we got onto the system, we got on as user www data. We got on as the web server's user. And then we ran su to switch user to Smith. You know, I don't think that that the web server needs to be able to run su. For that matter, we may even say that only the sysadmins on the system administrators, the DevOps engineers, or whatever you want to call them, only the administrative staff should really be able to run su. So what we could do is we could take su, and this is really good practice to do this with all of the setuid binaries on a system, but su is a good one, and say let's make it so that it's not world executable. It can still be setuid to do its job, but it can only be executed by people in the, and you could make it the admins group, or if you want to be looser, you could say the human users group, and put all the users that are actual human users with shells in, and not the web server. And that would have broken us. We would have landed on the box, but we wouldn't have been able to switch over to Smith and then proceed from there. There's another thing that we could do, and this would be to break the exploit more at the core. So instead of breaking the shell coming back to us, or instead of breaking the next stage in the attack, we could try to break all the exploits that would target this vulnerability. And we do that with something that does what is unfortunately called web application firewalling, and it's basically where you create rules that if the request matches that rule, then the rule triggers and says, nope, that request is not going to be allowed. So mod security actually is something that's in most Linux distributions, and it's basically a free web application firewall that you can install, and you can put it on a web server. It doesn't have a big impact on performance, and we could basically set it up so that PHP mail or that vulnerable software wouldn't have been, its vulnerability wouldn't have been something that could be that could be attacked. So here's how that attack worked. Basically the attack works, and I'm going to look at that final bullet on this slide. The attacker is going to send a hostile string via a hostile string that ends up in the mail command, that ends up in the send mail command in this case, but it's not dependent on send mail. And the attacker's command, the reason the attacker's command works is it goes where the email address is supposed to go. And it turns out that you can, similar to SQL injection or other things where you escape out of data and kind of get to code, you can put in an email address that has spaces, and you can put in an email address in that has a / quote. And so if you were to put in something like this string, the very last string on this slide, you would end up, that would actually be accepted even though it's clearly not a valid email address. So let's go back up to the first bullet. The hostile string that this exploit uses, it's by a guy who calls himself a narcoder, and this is the email address that he sends. And this email address ends up, most importantly, putting in a -x www backdoor.php into the sendmail string. And what happens is that sendmail writes a transaction log into backdoor.php, and then we control what goes into that transaction log and make sure there's some PHP code. So the PHP code gets written into the backdoor PHP file. But you could break this if you could break this attack if you could make it so that the web application wouldn't accept any email addresses that had spaces or had a / that basically didn't look like an email address. And so mod security lets you make rules and say if anything matches this rule, then it's a no-no. And here's what we could do just for this one form, and we could do it for all the parameters on this form and all the parameters on the other forms. We could create a mod security rule that looks like this. It says location, contact.php. Whenever you're working with this form, which is later on we're going to turn out to be vulnerable, but this is something you do proactively. You can do it non-proactively if the vulnerability is known and there's no patch. But if you don't know about it ahead of time, you basically look at the forms that are on the application and you go to each one of them and you profile them and you create a rule like this. You say, hey, on this form for the get argument email, if it doesn't match, and this is a regular expression, if it doesn't match a pattern that is 1 to 50 alphanumeric characters and then an @ sign, and then 1 to 100 characters that are alphanumeric or a period, then I'm going to call that definitely not a valid email address, and I will deny it. And if you put that in place, that would totally break what we were doing. And if you look at one of my past Beyond Trust webinars, I go through and do this kind of thing with mod security. But this is a pretty simple thing. You can also with mod security do this is what we call a whitelist. It's where you say what is allowed. So we're going to each form and saying for each variable. You can try your luck at letting mod security catch it with its big list of things that are bad. But it's a heck of a lot harder to name all the things that might be attacks than it is to just simply say, okay, here's the input this application should receive. If it gets something that isn't that, I'm not going to let it through. So that's another way we can break our attack. So I'm just kind of showing you 3 different ways we can break our attack. And these are all, each of these 3 things we're doing are honestly Linux security best practices. These aren't dependent on knowing an attack already. These are things you can do to every system that you have. And you will break this attack, and you'll break a whole bunch of others that we don't even know about just yet. So additional resources, I'd like to say you can find more blog posts and webinars I'm giving at Beyond Trust's website. You can definitely follow me and InGuardians on Twitter. You'll find the Vulnerable Virtual Machine Donkey Docker and a whole bunch of others at VulnHub. You know, here's where to find Kali and mod security. So with that, I'd like to turn it over to Paul from Beyond Trust.
All right, thanks, Jay.
Okay,
so that's great stuff as always. So anyone that's attended any of these webinars before know that we have a small infomercial spot at the end, and I promise this isn't going to be all salesy. It's really just I like to try and continue on a little bit from where Jay left off, and just like how Beyond Trust can help you, but also like share some information that I think I've learned over the years that may also be of some use. This isn't all about trying to push product, just really let you know a little bit more about what's out there. So for anyone that doesn't know, us here at Beyond Trust, we do a lot to help stop exploits or security breaches, intrusions, bad stuff from happening effectively, and we do that in a number of different ways. And again, I'm not going to spend a lot of time talking about all of this stuff that you see on the screen, but just so you're aware, we do a lot around, managing passwords and accounts and the security of accounts, endpoint privilege management, obviously, and, what we're kind of going to be focusing on today is our server privilege management, as in, Jay was just on, a number of Unix, Linux servers, and that's, again, the focus that I'm going to be talking about is at least at a very high level for a few minutes, talking about some of the stuff that we can do, to help improve security around that platform. So, again, to really pick up exactly where Jay left off, he really highlighted the fact that an exploit, any type of exploit, normally goes through a number of steps. Some of those steps are easier to prevent or block than others. Effectively doing nothing or not doing some of those best practices is going to be your biggest downfall. But effectively, every additional thing that you do, every security tweak or change or software that you install, really increases your chance of putting a blocker in place to break that, what I'd really call an exploit chain, right? So for an exploit to succeed, you have to do step 1, step 2, step 3, step 4. And when Jay went through some of the things at the end there on, how you could potentially block the exploit that he showed you, he also mentioned the fact that, it may, or almost certainly will block other exploits that either we know about or even haven't been discovered yet. So, so that's really the key, right? Is be proactive, do stuff, and really that's really a lot of what our products are about as well, right? It's being proactive in putting additional things in place to help manage the security of accounts and the management of those systems. I'd say probably the biggest differentiator for us as a company, maybe over what Jay was recommending, is we're all about centralization and ease of management, or ease of doing that security. So being able to put those security controls in place, but do it once and centrally, rather than having to go and hit every box and make sure that the right firewalls rules are in place. Maybe that's not a great example, but making sure that the right controls are in place to make sure that you're not exposed to some of these exploits. So I'm going to talk a little bit, or really I'm going to try and rush through these slides so that we can do a short demo of some of the things that we do here at Beyond Trust. I think, again, I prefer demo to slides, but just high level, Power Broker for Unix and Linux is really dealing with the management of credentials, privileged credentials particularly, tracking user activity or admin activity, auditing. One of the things that you'll probably hear me refer to multiple times during the next few minutes will be doing stuff at the system level. So system level controls. A lot of security tools will look at what users are typing or commands that they're running rather than what the system's actually doing. So I'm going to talk about how we can help implement those system level controls. And again, I'm going to focus specifically on Unix and Linux. Our Power Broker for Unix and Linux will actually work on things, really anything that has a command line, and then obviously we do extend well beyond the Unix Linux platform. We're not naive enough to think that that's the entire world for everyone. So just be aware that we can do a lot more than just Unix and Linux stuff. So before I get into this, because obviously we are very focused on a sudo type replacement, I often ask this question: is sudo enough when we're talking about dealing with privileged accounts? There's a couple of things on the screen that, again, I don't really need to talk through, and I'm not trying to knock sudo at all. I think I said back at the beginning, doing something is far better than doing nothing, right? So people that implement, say, sudo as a security tool, I would much rather see that than having people just logging on directly as root or logging on an SU into root. It's that's not a great thing to do. But there are security tools out there that are bundled. They're free, but again, you run into certain limitations, and management can definitely become problematic. So just bear that in mind when you're evaluating what you're using security wise. Stop and think about if it's really achieving your goals, or well, I guess, or not. So Power Broker for Unix Linux, again, marketing slide here, but really talking about some of the, the areas where, again, we really do that full privilege management, I guess, perspective. So, again, I won't sit here and read everything off the puzzle pieces that are on the screen, but we'll talk about, maybe some of the key things. The fine-grained least privilege really just means that it has a very powerful centralized policy language. So you define your policy in one place, and it's very, very flexible in terms of what you can achieve with it. The remote system and application control, that's actually a good one because it does tie slightly back to what Jay was showing. So one of the things you would get if you used a tool like Pabro Convenience Linux is the ability to manage systems that are remote without SSH into them. It's really important because it means you can actually manage a box that is basically locked down to the point where it will only serve up web pages through the firewall, right? Only talk to the firewall, but you can still manage that host in terms of checking the logs or performing backups or performing updates without SSH even needing to be enabled. You can actually use our centralized security policy to say, hey, go and kick off a backup on this host, and it will do it even though SSH is disabled. Obviously, disabling SSH really starts to limit a lot of those exploits that are right there if people can't even SSH to the host. Dynamic access policy, again, having that policy be dynamic, checking things like group information or referencing stuff in databases to determine who's allowed to do what, that whole who, what, where, when type stuff. And the last one I will mention, because again there's a tie back to what Jay was up to, file integrity monitoring or file and policy integrity monitoring. So with any good security tool, it's important to know that that security tool itself hasn't been compromised, but also, other files that are being controlled by that security tool aren't being compromised. So with any, when you want to run that backup script, for example, make sure that hasn't been tampered with before you allow it to run. Or, again, tying it directly to Jay's example, monitoring for things when the password file or the shadow password file is tampered with, and alerting on that straight away so that you can you can at least get on top of an attack or a breach that's actually in progress. All right, so enough of that. A couple of again real quick slides. Again, probably talked to some of these points already, so I'll go very quickly over this. But centralization is just really important to be effective in putting out good security controls. Again, in Jay's example, we're dealing with a couple of hosts. Most people are dealing with hundreds, if not thousands, of machines, and it's just not realistic, even with a large admin team, to be able to go and be constantly putting those policies in place and making sure everything's set up correctly on every one of those machines. You want security tools. Again, this isn't so much a beyond trust thing. Just make sure you go with centralized management, because it's ultimately what will allow you to keep things up to date and really make sure that everything is being enforced on all of your machines, right? Because attackers don't care what machine they're attacking through. If there's one lowly system sitting out there that's not patched, doesn't have the right security things in place, that's absolutely the one they're going to find and try and compromise. Advanced control and audit. So again, one of the things that we offer, and I call this one out because I think it is really important. I'll actually, I think we've got time. I'll jump into a demo here in just a minute and show you. We can actually audit what goes on at the system level. So things like, when a script runs, making sure that things that kick off inside that script are tracked, but also controlled as well. We won't talk too much about that. I'll just cut straight over to a demo here in a second and show you that working. And file integrity monitoring, again, I've already talked a little bit about this, but you want that centralized. You want to be able to alert when changes are detected, but tracking, when things change. Things are added to the system, things are deleted, things are modified, or things fall out of policy. Out of policy would be, again, I know Jay made mention to this a couple of times, but when certain binaries or files have poorly set permissions, it's much easier to use a FIM type tool, scan all your systems and identify those weak points and go and address them, from that one central place, rather than having to go and hit every system and say check the file permissions on every instance of the SU binary, for example. All right, reporting, obviously this, I shouldn't really have to talk to this with any commercial tool. You expect it to come with a whole bunch of reporting and tools to help you with forensics and, identification of those weak points so that you can go in and fix them. And then we've got our architecture slide, which I don't think need to bore anyone with. I think I've already made my point that centralization is definitely the key, and that's with at least the solution I'm going to show next is really what we're going to get into. So with that said, I've got about 5 minutes or so, so I'll just show you a couple of things. I keep it slightly more high level, but a few things that again would help from a Beyond Trust perspective that we offer to stop the exploit that Jay showed, but maybe just exploits in general. So one of the first things I showed, I'm just going to go in, log on to a couple of different systems. Now you'll see, first of all, when I connect through PuTTY, I'm just going to grab 2 different sessions here. I'm getting logged on to these servers, and it's doing a form of single sign-on or reduced sign-on. It's going to do host name, so we can see I'm on server 1 and server 2. Basically, I connected here using my Active Directory credentials. So there actually is no demo 1 user who I'm actually logged on to Windows as in my etc password file. So one of the great things here, and I'm not going to start preaching about centralized authentication. I'm sure everybody's aware of this, but by keeping all of your accounts in one database, such as Active Directory, means that there's no account on the box to actually be compromised, and there's no SSH keys because it's all using Kerberos. That was a true Kerberized authentication that got me logged on, so no passwords flying around, and again, maybe more importantly, no SSH keys hanging out there to be compromised. So that's just right at the gate one area where we've kind of improved a little bit. All right, so let's go back to server 1. So obviously if I run the whoami command, it's going to tell me the user I've logged on as. Now what I'm going to do is I'm going to say I want to run that elevated. So I do a pbrun whoami, and pbrun, again, is our replacement for sudo, if you want to think of it that way. Basically that goes through and does a number of things, right? So when I run the whoami command, it looks at well, first of all, it comes up with a total risk score or risk level. In this case, it's risk level 1, and it builds that on a number of things. So a risk score based on the host itself, for the user issuing the command I issued being whoami, came up with a total risk activity score of 2700 and set that risk level as 1. And again, all of these numbers are completely configurable. So it deemed the whoami command on this server as being low risk, so it allowed it to run, and it also logged that into syslog, so that could then go off to your SIM. But effectively, it went off to a centralized server. In this case, it's actually this server itself, which is why the server has quite a high risk score associated with it, 2500, and it elevated the command to run as root. Obviously, the output was root, and that's it. We're done. If we were to do the same thing over on this server, which obviously isn't my centralized server, basically the host risk score is much lower. This is just one of my client machines. The user risk score he doesn't have one, and then the command risk is obviously the same. And so the total risk activity here is lower. The risk level is actually 0 on this box. And therefore, again, the command runs, but it's really just going to say, look, this is very low risk activity. I'm logged on as a regular user, and I ran the whoami command at a higher privilege. So really nothing, nothing too sensitive there. But it's really just showing you the fact that you can come up with a risk level based on a number of factors and choose how you actually want to. Well, first of all, if you can allow something to run, and also the type of auditing activity or notification activity you want to do. Obviously, I'm displaying all of this to the screen. You probably wouldn't want to do this in the real world. Just really highlighting what's going on in the background. So we can do a couple of other things. If I was to do like pbrun ID, you'll see this runs. If you're good with numbers, you'll actually see now that this command risk on this one is only 100. So slightly different number, but ultimately the output's going to be about the same, still the same sort of risk levels or that sort of stuff. And if I was to do pbrun true, really just to demonstrate, it's just a command I put in there and gave it a unwieldy risk score. Not that true is in any way sensitive, but again, that's now bumped my risk level all the way up to level 4. It's sent off an email, it's sent something to syslog, it can open a ticket in ServiceNow, can notify the SOC, whatever controls you want to put in place, and then ultimately choose whether or not the command's going to be authorized. And again, that can be based on, not just the command, but, a combined risk score on the host, the user, and the command itself, or any other actually parameters that you actually want to use to build that risk score. All right, so one more thing I kind of want to show. So on this server, I'm going to do a PB run bash, right? So what this will do is actually elevate my entire shell to a root level shell, right? So if I was to do ID, you'll see that I'm in as root, and basically I have root level privileges. So if I was to run who am I, you'll actually notice that who am I actually gets rejected, and I'm going to show you why in just a second. But the who am I command is there. In fact, I guess we'll take a look at it right now. Probably got a better example of this later, but the who am I binary is there. It's owned by root. You can see everybody has execute permissions. Only what we can do is when we give privileged shells, or when we let somebody on as a particular user, in this case root, but it could be any privileged user. Again, in Jay's demo, this could be that www user. You can actually control what that user does regardless of the file ownership or the file permissions itself. So you have a lot more control. Again, putting these types of controls in place, much easier to define this centrally. Probably as I'm talking away, you can relate this to being able to go to one central server and put a control in place that says that the SU binary doesn't have worldwide execute permissions. Lock it down to whatever permissions you want, and we'll actually supersede or override anything that's actually put on the file system itself. So that's kind of cool. The other thing I will show you real quick is we go to the scripts folder. I know I'm running close on running out of time, so I'm just going to show you some in as root. I've got a script here that's owned by root, and root's the only person that can execute this. So this falls nicely into one of those categories where somebody tells you, hey, I need root level access. I've got to be able to run this script that does a backup, that creates a database table, whatever it is you want to do. I'm going to go ahead and run that script, which again, we're just going to see that the script runs and the script completes. Now, I'll actually show you just so that to make this demo a little bit more complete. If we take a look inside that script, you'll actually see that there's actually some malicious stuff in there, which is somebody trying to reboot the system. If I try and run that, you'll actually see that permission's denied. And again, I can do the same thing. We'll take a look at that itself. The reboot, did I do that wrong? No, there it is. So you can actually see that reboot is also owned by root, and everybody should be able to execute it. But again, we actually block that. And just in the interest of time, because I know I'm down to the last couple of minutes, I'm going to do something really bad here and switch to native root on this system, really just to show you. It's the quickest way I can get to these logs. So within that session, the whole session was being recorded. So on this central server, I can do something like PB replay and just replay that log file, and we can go through and see everything that happened within that session, right? So again, that's just a replay. I can go backwards, forwards, that sort of stuff. But what I really want to show is within that PB replay of that session, I can say, show me the history, if I type it right, and that will show me actually just the commands that happened inside that session, which again, here we can see that I ran the demo 1 script, right, which is great. I can see that I ran a script, and we know luckily that the reboot inside there was actually blocked. But what I can do is actually say, show me a more detailed version of the history, and then here not only can we see that the demo 1 script ran, but then we can also see things that happened inside that script. So here I can see inside the script, I actually tried to run the who am I command, which is blocked. And more importantly, because that would make my demo really short, the reboot command was blocked as well. So, okay, all right, that's probably enough demo time. So I will actually jump back over to the slides, and we'll turn this back over to Sarah to wrap things up.
Thanks, Paul, so much. Okay, guys, let's jump into our last poll. Here at Beyond Trust, we'd love to help you with your privileged access needs. Would you be interested in engaging with one of our security experts further? We'd love to chat or walk you through an even more thorough one-on-one demo of PowerBroker for Unix Linux or one of our other PowerBroker or our Retina products. Let us know, select yes, and somebody will be in contact with you. I'm going to leave this up. Let's dive into a couple of questions. I know we are past the top of the hour, so you may leave if you need to, but let's go ahead and cover a couple of questions that came in while the guys were presenting. Jay, when you found the Smith user, how did you think to try his username and as his password? It's
a really good question. So the honestly, password security is, if you look at these boot to roots, when I go looking for the boot to roots, I actually struggle to find, struggle is the wrong word, but it takes me a bunch of effort to find ones that don't hinge entirely on password security. So they tend to mimic what we find on what we find in penetration tests and red team exercises, where users will set their password or their username if the system lets them, and so I tried that here. But if I were to try a number of other passwords, I will tell you to, like, password isn't it. It's not like the 80s, but I sure as heck would try winter 2018 right now for anyone's password, because a lot of users will set their password to, like they get forced to change their password often enough, they just set it to something really predictable, and it's kind of, they're annoyed that they have to change their passwords. So for Smith, I tried that because that's one of the first things to try in one of these CTFs. But there are a host of bad passwords that would have been worth trying, and you can even script that up as an attacker. Thanks.
Jay, during your exploit, you connect back to yourself. While this works fine for noisy attacks, what is your approach when you are trying to avoid a path back to you?
Oh, I like this. Okay, so the person asking this question is noting that I am not being sneaky at all, and I'll tell you, so I'm an attacker for the most part. That's my main job at InGuardians, and we do engagements where we're doing pen tests, and then we do engagements that are red teams. And the red teams, we're actually trying to emulate what real attackers would do. And yeah, just like you say, you, as a real attacker, you wouldn't want to make it so easy to find you. So instead of having, I'm going to probably need to have that exploit connect back to some system I own, but it sure isn't going to be mine. It's going to be some system that I've bought, usually in a cloud provider, that if I'm a true criminal, that I've hacked somewhere else, and that system is going to be one that's used only for this engagement or for this crime. And at the end of that crime, we're going to burn it. We'll never touch that system again. The system will have a name. It'll have a domain name that sounds legitimate. It will be a domain name that has existed for more than a day, so that it won't get caught by the things that look for newly registered domain names. So it'll have some domain name that we've gone and bought far in advance and categorized, so that the different firewalls that that say, is that a gambling site, or is that a shopping site, or is that a hacker site, we'll make it so that it definitely was a shopping site, and we'll make sure that we connect back to that. Other than that, to address the question another way, if I wanted to, with that exploit in particular, I didn't have to have it connect back to me, but it sure was a lot easier. I could have made that backdoor PHP into a web shell, where I would just be entering one command and seeing its results in the browser, and enter another command and see its results in the browser, and then from there I could create an API and whatnot, and have it all happen via HTTP. It's a little bit harder, and it takes a little more effort, but it's definitely worth it as an attacker. The attackers really will, though, have something connect back to a system they own, because most of the remote access Trojans just work a lot better. And when an attacker compromises your system, they generally, are going to be doing a heck of a bunch more work with it. It may, even if that only takes them a couple hours, or if it's like most attacks where they're on there for months, they're going to want something convenient, and having it connect back to their, to their tools that make it easy for them to manage is pretty much par for the course. Okay, cool, thank you.
Cool. Okay, time for one more question. Have you ever used ping payloads or DNS query payloads for CNC?
Okay, so the question that's being asked is, have I ever used either ICMP, ping, or DNS as a way to do CNC, which stands for command and control? And I'll answer, yeah, absolutely. On a red team exercise recently, we used we haven't really used ICMP because the packets only get so big, but we've certainly used DNS, and the great reason for using DNS is that nobody really watches their DNS all that closely. It's It's really wonderfully sneaky, and it tends to be allowed out of every single system because, well, systems generally want to be able to look up the names of things connecting to them. So yeah, that's we've definitely used that. The downside of those is that they are a heck of a lot slower than a nice, than a good old TCP connection. So while we'll use it, we'll use such a thing mostly for the systems where this is the system you compromise first, and or it's one of the ones that you're not going to be using directly. You're going to be using it only if you lose access, because you need something a lot faster if you're going to be working with the system quite a bit. So yeah, definitely the DNS one a lot. The ICMP, I've never done it, but you totally could. That was a cool question.
Thanks,
Thank you.
Jay. Oh, good. Yeah, thanks for everybody submitting your questions. Let's wrap this up. A reminder, you will receive an email with a link to the recording and the slides shown here today within 1 to 2 business days from now, and it will come from our email alias, communications@beyondtrust.com. And a big thanks again to Jay and Paul. Great job today, you guys. Thanks for being here. And we always love your content and your topics, Jay. So thanks for making everything clear and being super concise with your presentation. So thank you guys so much. Have a wonderful rest of your year. Thank you for attending, and we will see you in the new year. Take care, everybody, and goodbye.
Thanks.